We were introduced to the double angle formulas yesterday, and we know that we're going to use these formulas when we see things like sine 2 theta, cosine 2 theta, or tangent 2 theta. That's the double angle. Okay, first thing you always do is draw your picture. So I drew a picture. Now, I knew it was in quad 3 because in quad 3, because it's between pi and 3 over 2. Do you see that? So I drew that in quad 3. Okay. My tangent is, okay, so I drew it, put my theta here. Tangent is opposite over adjacent. Yes, I know my tangent is 1/2. It told me that. But since it's in quad 3, my x and y are both what? Negative. That's why you see -1 and -2 instead of 1 and 2. Does that make sense? You got to think about those kind of things. Alright. Once you draw the picture, and I found my hypotenuse to be square root of 5. It's okay. You're going to have square roots, radicals in there. Once you do that picture, that's when you come over and find your 3 trig functions. Sine, cosine, tangent. Those are not your answers. Those are the values you're going to take and plug it into the formulas, okay? So sine. Sine is opposite over hypotenuse. -1 over square root of 5. Well, I got to rationalize that, don't I? So I'm going to multiply by square root of 5, and I get negative square root of 5 over 5. That is my sine value. Then I do my cosine. Adjacent over hypotenuse. -2 over square root of 5. Rationalize, I get -2 square root of 5 over 5. Then my tangent is opposite over adjacent, so I get 1/2. They gave me that, so I shouldn't miss that. Then I go to find these formulas. Sine of 2 theta. I have one formula. So I plug in my value for sine, negative square root of 5 over 5, and my cosine is -2 square root of 5 over 5. Okay, that 2 is 2 over 1, isn't it? So 1 times 5 is 25. 2 times -2 is -4. -4 times that negative is going to be a positive value in the numerator. Do y'all understand that? What's square root of 5 times square root of 5? 5. So I say 5 times that positive 4, and I get 20 over 25, which reduces to 4/5. Okay? Cosine 2 theta. You have 3 formulas to choose from. You're going to get the same answer. I choose the first one every time, but you can do any of them. I do cosine squared minus sine squared. I plug my cosine value and then my sine. Let's be careful how we square this. Okay, when I square this, you got to square the numerator and the denominator. -2 squared is 4, isn't it? What happens to that square root in that square? So 4 times 5 is 20. 5 squared is 25. Negative squared is going to be a positive. That's going to be 5 over 25. 20 minus 5 is 15 over 25, which reduces to 3/5. This is not hard, and it's not a hard test, but you got to go home and know when do I do what on these problems. You've got to learn the process. Tangent of 2 theta. That's one formula. This right here. Tangent is 1/2. 2 times 1/2 is 1. 1 minus tangent squared. 1/2 squared is 1/4. 1 minus 1/4 is 3/4. When I say 1 divided by 3/4, I end up flipping that fraction on it. And that's how I get 4/3 there. Are there any questions on number 52? Let's look at 53. It is in quad 4 because it's between 3/2 and 2. My cosine is adjacent over hypotenuse. I put the 2 here, put 5 here. I use Pythagorean theorem, and I find this to be square root of 21. But this is dealing with my y. My y is negative in quad 4, so that's why I put a negative sign with it. Negative square root of 21. Once I do that, I got to list my 3 trig values. Well, they gave me cosine, so I know to put that over here. Now, sine is opposite over hypotenuse, so that's negative square root of 21 over 5. I know it's negative because in the 4th quadrant, your sine value is negative. Then tangent is opposite over adjacent, negative square root of 21 over 2. So I got my 3 trig values. I have my picture, now I can do my formulas. Sine 2 theta, I substitute that in. That's 2 over 1. 1 times 5 is 25. 2 times 2 is 4, times that negative is a negative 4, square root of 21. Cosine of 2 theta equals cosine squared minus sine squared. 2/5 squared minus this squared. That gives me 4 over 25 minus 21 over 25. Does everybody understand how I got 4 25ths right here? And why this is negative 21 over 25? Okay, well the minus came down. The negative squared and then the minus came down. So that gives me negative 17 over 25. Okay, tangent 2 theta. 2 times the negative square root of 21 over 2. 1 minus this squared. It looks ferocious, but it's not too bad. These 2's cancel out, leaving that negative square root of 21 there. I square this. That's going to be 21 over 4. 1 minus 21 over 4 is a negative 17 over 4. Well, this divided by this ends up flipping this. So negative times a negative is a positive. 4 times that's 4 square root of 21 over 17 is my answer. Are we good at 52 and 53? Okay. Alright. I want to review something here for just a minute. Make sure you understand this. If we're working backwards on the sum and difference. Okay, this starts with sine, so we know what, everybody please pay attention. We know that this starts with sine, we're dealing with sine. There's a minus. A minus. What would you do with these two things? Subtract and then evaluate. You got me? Here, this is cosine. I know it starts with cosine. A minus. What will I do with those two things? Add. Okay, you know that we're working backwards. Those are easier, aren't they? Well, that's what you're about to do. I want you to turn to page 18. Let's look at number 6 and 8. These go along with what we just did, but you're working backwards on these. It says use the double angle to find the exact value. All right. You got to match it up with one of these. One of these. That first one is matched up with which one? Sine. What do you think we just do with these problems? What do you think we do with the value 22.5? It's called double angle. So what you think we want to do? Double it. What's 22.5 plus 22.5? 45. So you're going to double it. So that gives me sine of 45. What's sine of 45? There's your answer. What now? You're just doing that one. Well, no, because you had to match it up with which one? Sine. That's not the cosine double angle formula, so you would not do cosine here. On number 7, which one of those looks like this? It's this one right here, isn't it? Does that look like that? So that means you're going to write the word what down? Cosine, and do what with that pi over 12? Double it. What's pi over 12 plus pi over 12? 2 pi over 12, which is pi over 6. Good. So I'm going to write the word cosine down. That's going to be 2 pi over 12, which reduces to pi over 6. And that would be square root of 3 over 2. That one is the tangent. What I'm going to do with pi over 8? Double it. That's going to be pi over what? 4. Tangent of pi over 4 is, aren't those easy? But for some reason, I students miss a lot of these. The working back problems, you just work back. Mr. Chester, how am I going to know when to do what? It's going to say, use the double angle formulas. You just work backwards, you double it. And then the other ones, you're going to match it up with sum and difference formulas. Sum and difference. You're either going to add or subtract them. Do y'all see that? Are there any questions on that? Alright, the last thing we're going to do is the half angles. So turn back to page 17. Make sure you have those 3 formulas copied down. The half angle identities. Yes. Yes. All right. You good, Derek? Yes. Okay. Here we go. I want you to look at something here. Shh. It's funny, they all involve cosine, don't they? He said, Mr. Chester, when are we going to use these two things? If you take higher math one day, you'll see these formulas again, but this is the only time we use them this year. But half angle, sine of theta over 2 equals this. What do you think is the relationship between this theta and this over here? They're half. Isn't this half over here? So just keep that in mind right now, okay? Alright, so let's look at this first one. It says use the half angle identity to find the exact value. Sine of 5 pi over 8. So let's write the formula down first. Okay. Now, in the problem, you have sine of 5 pi over 8. You're thinking, what do I plug in for theta? You do not plug 5 pi over 8 in. 5 pi over 8 is the half angle. It's half of what? So you're going to multiply 5 pi over 8 by what? 2. That's what you got to remember that. Because of the relationship of the formula, this is theta over 2. You want theta, so you got to work backwards and multiply whatever they give you, say for half. You're going to multiply everything by 2, and that's what you plug in for the formula for half angle. Okay? So 5 pi over 8, I'm going to multiply that by 2. That gives me 10 pi over 8, which reduces to 5 pi over 4. Can you work with 5 pi over 4? That's why you have to do that, because you didn't know what 5 pi over 8 was on unit circle, did you? But you know what 5 pi over 4 is, so that's what you're going to plug in now. Plus or minus 1 minus the cosine of 5 pi over 4 over 2. 5 pi over 4, that's in quad what? 3. What's your cosine of that? Negative root 2 over 2. Now, it's going to look messy. These formulas look messy, but you have to take your time. That's a double negative, so it's become a what? Positive. Now, what do we need to do that numerator? We've got 1 plus square root of 2 over 2. We need to do what? We need to come to the side and find the common denominator, which is 2. That is what I plug into my numerator. Do what now? Okay. Now, it is this divided by this, isn't it? So I'm going to come over here and I'm going to write that. 2 plus square root of 2 over 2 divided by 2. Change it to division and multiplication and flip it. So all this is under this radical is equivalent to that now. We've got it broken down. Does that make sense? Are we sure? Okay, so I'm going to go back and put this under the radical.
Teachers, at this time, please go ahead and post your attendance for the morning. Please check for email from this heading. Go ahead and post attendance at this time.
All right. Now, you said, Mr. Isher, how do we know what their final is going to be, plus or minus? The plus or minus is going to depend on what quadrant the original thing is in, okay? And we'll talk about that in just a minute, okay? But let's talk about this. I can't take the square root of 2 and the square root of 2, can I? But can I take the square root of 4? What's square root of 4? So you just leave this other stuff. That's your answer so far. That's it. I'm not going to make you go any further than that. But you did take the square root of 4, which is 2. Just leave the square root of 2 plus the square root of 2. Now, let's think about where 5 pi over 8 would be in the end circle. 4 pi over 8 would be pi half, wouldn't it, at 90. Would you agree? So where would 5 pi over 8 be in quadrant? 2. Your sign is what in quad 2? Positive, so it would be positive. That would be your answer. Yes.
So the square roots wouldn't cancel?
No. Square root and the square cancel, but not square root and square root.
You still need the plus and minus.
No, you just do a positive here because the sign in quadrant 2 is positive. Alright, number 4. The tangent of 22.5. I'm going to go to my tangent formula, which is plus or minus 1 minus cosine theta over 1 plus cosine theta. What do I do with the 22.5? Multiply. So what I'm going to be plugging in? 45, yep. Now, you can go and determine this now. Tangent of 22.5. Where would 22.5 lie? In what quadrant? 1, okay? It's in quadrant 1, and the tangent in quadrant 1 is always what? Positive. So you would just do the positive sign here. If you want to determine that up front, you can. Alright. 1 minus square root of 2 over 2. 1 plus square root of 2 over 2. Cosine of 45 is root 2 over 2. Still with that on? Good. Alright, now, what do I need to do? I need to come to the side and find a common denominator of the numerator and denominator. Now, some of you can do it in your head now, that's fine. But if you need to come to the side, and what I mean is 1 minus square root of 2 over 2 would be that right there. And on bottom it would be 2 plus square root of 2 over 2. Now these look ferocious sometimes. So I found a common denominator in my numerator and my denominator. Alright, I'm going to come to the side and divide this out. Flip that second one. What happens to these 2's? They cancel. You're left with, and I will accept that as the answer because there's no need to teach you how to rationalize a denominator under a radical. You don't have to worry about that, so you can just leave it like that. I'll accept that. Because it gets very, very complicated, and you never see it that much.
Wouldn't it just, if you were to do it though, wouldn't it just be like on?
No, because you have a square root and then another square root, so you just have to. It's not like the normal rationalizing. Did y'all ever rationalize denominators in algebra 2 like it was like the 5th root or something? No, because it is a complicated procedure, and all you ever work with is usually square roots. So, all right. Are there any questions? Number 4. All right. Let's look at number 5. The last one for the day. Cosine of pi over 8. I'm going to double it. What's pi over 8 double? Times 2. Pi over 4. So that's what I'm going to plug in is the pi over 4. Okay, my cosine formula. Now, pi over 8, what quadrant would that be in? 1, so I'm going to go with the positive. One plus cosine of pi over 4 over 2. Cosine of pi over 4 is square root of 2 over 2. I'm going to find the common denominator in the numerator. I've done that many times now. I'm just going to put it here, 2 plus square root of 2 over 2 over 2. I'm going to come to the side, flip it. That gives me 2 plus square root of 2 over 4. Can you take the square root of 4 in the numerator? Could you take me the square root of that? Yes, I'm going to leave the square root in the numerator and just in the denominator take the square root. That's my answer. It's not hard, but you stay home and review the steps to doing each of these problems. So you know about this on Friday. Okay, I want to add something to your assignment here. Okay. On page 20, let's look at page 20. I want you to work on this now. You're not going to put stuff up. You got what time we get out here? We get out at 9 to 4 here? What did you go any time to do homework? Alright, and you will be doing this. I want you to add number 54 to your homework tonight. That reviews what we did last night. 55 and 56 deal with a half angle. So it doesn't have the word half angle there, so if you want to write half angle by 55 and 56, do that. And then 59, 60, and 61. So 6 problems. 54, 55, 56, 59, 60, and 61. Work on those now. We're not going to restroom. We're not going to go visit people. We're not going to office. We're not going to student services. Number 59, that's the type I taught you a while ago, working backwards. That matches up to the double angle. Oh, that was a mistake. Let's just make them both 75. And let's make the second sine cosine, and let's just go from there. Thank you for catching that. Yes, Tyler.
So which one were the half angles?
55, 56. And on your test, it's going to tell you use half angle. So you won't have a